morning or good afternoon, depending on where you're joining us from. Thank you very much for joining us for the Rackspace Fanatical Support for AWS webinar on 7 best practices to secure your data on AWS. My name is James Cowe, and I'm the Director of AWS Strategy and Architecture here at Rackspace inside our AWS business unit. I'm a former AWS senior consultant specializing in infrastructure and enterprise transformation, and with me on the webinar today I have Brad Schulteis, who is a senior AWS and security specialist architect currently at Rackspace, formerly an Amazon solutions architect specializing in security. Unfortunately today, Mr. Todd Gleason from AWS is unable to join us, so Brad has kindly agreed to step in and share his wealth of AWS experience and security domain expertise with us as well. So, moving on. Today we're here to talk about encryption and how to use it to protect or safeguard your data on top of AWS. Before we get started, I think it's important to really understand what encryption is. So, at its most basic form, encryption is a method of taking some information and changing it from one typically readable format to another hidden or encrypted format that hides the meaning or the messages. So, encoding of information in such a way that only people who are authorized or have the keys in order to open it are able to access and read that information. Leads on to why is encryption an important thing? Why is it a valuable way of securing your data? And there are really a couple of main reasons for that. So privacy, integrity, reliability, and anonymity. In a nutshell, encryption is there because it protects our data. It protects it whether it's sitting on our computers or inside our data centers. It protects it whether it's being transmitted around the internet, and it protects our conversations, whether they're video or voice or text. And ultimately, it's there to do that, to protect our privacy and our right to anonymity. And sometimes, you know, realistically, encryption is there to protect and safeguard the lives of everyday people. Encryption is one of those technologies that really works at its best when it's ubiquitous and seamless and transparent to users. And it's something that really should, in this day and age, be enabled by default. It's something that you should consider turning on for everything that you can where possible, but ultimately there are some important trade-offs that need to be made when you do that. So today we're going to go through some of those important bits of information.
Thanks, James. So what is the key to encryption? Well, the data encoded with a key is useless without that key. So that key is ultimately very important. If you have the key, you have access to the data. Without the key, there is no data. It's just a bunch of random information. So whoever controls that key controls the data. It's also a hierarchy. So we start with plain text, and we're always left with something in plain text. Kind of one of the shortcomings, you can say, of encryption. You have your data, you encrypt it, and you're left with the key, which is in plain text. So, okay, let's encrypt that key with another key. Now we have another key in plain text, and another, and another. Where does it end?
Thanks, Brad. So when we talk about the best practices around encrypting your data on AWS, we're going to run through 7 of them today. We're going to start with probably the most important one, the thing that you need to consider first when you're looking at establishing data protection or encryption policies around your business. And that first one is establishing those policies. So there are really 2 kinds of policies that you probably need to establish first. So one is data classification. What type of data are you talking about? What's the impact of that data being compromised or publicly available? What's the sensitivity of the data that you're looking at? And then how's that data going to be used? How are you going to store it? How are you going to retain it or archive it or delete it over time? How's it going to be processed? Who are you going to share it with? And when you look at that, there are a couple of questions that really help to isolate those particular policies and those particular questions that you need to ask. So when it comes to data classification, you should start by asking, what data do you actually have? Are you storing personally identifiable information or PII data? Are you storing financial information, credit cards, or healthcare records? What are you intending to do with it? So if you're storing credit card information, are you intending to process payments with it? And how do you need to protect it? Or which data do you need to protect within that subset? So if you're recording personally identifiable information, do you need to encrypt usernames, or do you need to encrypt the full names and address details that are mapped to those usernames? And most importantly, who are you protecting it from? Are you trying to protect against a breach that lets your data out into a public domain? Or are you attempting to protect the privacy and security of that data from internal employees who just shouldn't be casually able to access that data? Asking these questions will really help you classify what the kind of data you're protecting is and how you need to go about protecting it. And then when we talk about data usage, we also tend to ask a couple of core questions as well. So what can I do with the data? Is it something that needs to be utilized on an ongoing, continual basis? So, for example, is it information stored in an e-commerce platform that includes shipping details? Or is it something that only needs to be accessed infrequently? Where am I going to process it? So does it need to be processed inside a data warehouse, or does it need to be transmitted across the internet? Does it need to be shared with external third parties for payment processing information, for example, or with other healthcare providers if it's healthcare information? And as a result of how you're processing it, how should it be accessed? Is it something that needs to be accessible in real time via an encrypted or a secure access mechanism over a secure link, or is it something that needs to be accessed infrequently and only by a given process? And then most importantly, can you and when should you destroy that data? So if you have retention policies in place, if you have a statute of limitations around keeping that data for a certain amount of time and then securely destroying it afterwards, how is that actually going to be implemented? How are you going to use that data going forward?
Yeah, so obviously establishing that policy is very important. Once we've established the policies around encryption, then we start evaluating our options for managing encryption. So there's a lot of things to consider here. Again, there's questions to be answered. So what are the different options out there? Generally, they kind of fall into three categories. So you either have something that you manage completely on your own, something that you're managing in conjunction with your service providers, or something that the service provider is completely managing. You're also able to influence where that encryption is done. So kind of the two ends of the spectrum here are client side and server side, whether you're managing it within your application and the code for that application itself on the client before it hits the cloud, or you're leveraging resources of the cloud provider to perform that encryption on your behalf. And all of those trade-offs are evaluated against your appetite for risk. So essentially, we have these two ends of the spectrum, and it's all about balancing risk, cost, and complexity. So client-side solution in a self-managed fashion, that offers the lowest amount of risk possible because you're completely in control of the solution and the keys. So that also means it's the highest complexity. It's a very complex system. You're managing all of that. You have to have encryption modules installed in all of your code. You have to maintain those libraries. You have to maintain the keys and manage that all on your own, which also comes with the highest cost. So you're going to be managing your own key management system. You're going to be leveraging potentially proprietary code bases, a lot of developer time. All of that comes with additional costs. You can kind of transition then to a different type of spectrum to leveraging some of the resources that come from the cloud provider. So in this case, AWS, use some of the capabilities native to AWS, but still maybe provide your own keys so that you're jointly managing the encryption. So that lowers your risk, but there is still a moderate risk because the encryption is essentially being done by the cloud provider. And that's still highly complex because you still need to maintain your own key management system and potentially incorporate lots of different APIs into how you're doing things. But it does also lower your cost. And an interesting thing here, a client-side solution is not possible with a cloud provider, at least not with any of today's technologies. If it's client-side, it's by the very nature, you're going to be managing at least some aspect of that. You can't put that all on the provider. On the other side, if you're doing everything over with the cloud provider's infrastructure, obviously you can't be fully self-managed in that case because something is being done by the cloud provider. So you again have jointly managed solutions of server side, and then you can go down, and it's very similar here. There's some moderate risk. It's a lower complexity than when you're doing client side. server-side is kind of transparent to the end user as well as the administrator, and the cost is kind of moderate there as well. And you can also go all the way up to completely provider managed, where the provider's managing the key management system, they're managing the encryption solution. It's all done transparently. That has the highest risk, but it's also extremely low complexity and low cost solution. And that gets back to doing encryption by default in a lot of cases. You don't even know it's being done. You're basically checking a box and the provider's taking care of it for you. A lot of those types of solutions are specific to data at rest. So when you're protecting your data at rest, again, more choices. Am I using my encryption software? Am I going to use the AWS API? I'm going to use my keys or AWS provided keys. So in the self-managed solution, essentially, you are encrypting data storage using your own software and your own keys. So that might be something like volume level encryption done at the OS level with a third-party software solution installed within your EC2 instances, where you're responsible for installing that software, maintaining it, and managing the keys. You can go to a jointly managed environment where you're going to use the AWS provided APIs to encrypt like EBS volume encryption behind the scenes, but you can provide your own keys. So you can provide the key by which you're encrypting, but it's still being done in the cloud. So at some point, the cloud provider has access to those keys. Or you can move completely to provider managed, where you're just going to get the keys directly from the cloud provider. So a lot of the services, basically almost any storage service in AWS offers some form of encryption at rest. So RDS, you can switch on encrypted volumes. The snapshots will also be encrypted. Same thing with Redshift. S3, at the object level, you can determine whether it's encrypted or not. You can also create policies around server-side encryption or client encryption. And EBS volumes we already talked about. You're able to just encrypt those volumes on the whole. Any questions so far? See anything coming up. So guys, remember to ask questions when they come up. We will answer. All right, the fourth best practice is ensuring you're securing your data in transit. So again, more choices. When, where, and how are we performing this encryption? This is nothing new. TLS or SSL termination can be done in multiple locations within AWS. You can actually choose to terminate the session all the way down at the EC2 instance. That's kind of that client managed option. Or if you have a load balance service and you have multiple EC2 instances, you can actually terminate that session at the Elastic Load Balancer. Redshift also supports TLS encryption, as does RDS. And all of the AWS services, all the API endpoints support HTTPS connections. You can also set up VPNs within AWS. So again, more options with more trade-offs. If you want to be responsible for kind of a fully client-managed option, then you're going to have to look at potentially leveraging your own software and hardware, and also your own key management system. Jointly managed, you can actually use some of the AWS APIs and provide your own keys. So that might be like generating your own keys to put on the ELB, but the ELB is actually doing the encryption and decryption for you. Or you can put it all on AWS's shoulders and use an ELB with a certificate management service where they're automatically managing your certificates for you. So transit in AWS is kind of a different animal. So the old concepts of network perimeters are kind of thrown out the windows. You don't exactly know where your data is going at all times. So it's always safe to assume that any data transfer could potentially leave what we think of as the data center. It may go outside of your perimeter just because of the way that software-defined networking within virtual private cloud, the VPC, and AWS works. Data transfer between availability zones is definitely going to leave the data center because the AZ is like a data center construct. You're going to definitely be traversing some form of a wide area network. And then between regions, obviously, you're definitely leaving the data center. And also between customer networks. So if you have multiple VPCs, even within the same account, you're actually going to leave your VPC, go to the edge, and come back into another VPC. So at some point, that traffic will be sitting on the edge in an unencrypted fashion if you're not using encryption.
Okay, thank you, Brad. So at this point, again, I just ask anyone to submit any questions they have into the chat, and we'll obviously answer those as they come in on the way through this presentation. I'd also ask people to tell us maybe if you're doing encryption today in AWS, or if you're doing it today outside of AWS and thinking about moving into Amazon. Tell us about the way you're doing things or any particular challenges you have, and what we'll do is try and talk to some of those scenarios towards the end of the webinar, just so we've got some real world examples from the guys attending the webinar. It might be interesting and instructive for other people. So moving on, talking about native encryption options inside AWS. So Brad's touched on a couple of different ways in which you can approach encryption and the areas in which you need to focus on encryption within AWS. But we've also touched on the fact that there are a couple of different modes in which you can do it. So you can manage your own encryption end-to-end, or you can leverage part of the cloud provider's services, or you can entirely rely on the cloud provider to provide those encryption management services and implementation services. When you start to come around the question of using native encryption features, you then start to talk about ease of use versus risk for appetite for risk, apologies. So the appetite for risk refers to the decision to trust your cloud provider, in this instance AWS. Question the basics, so making sure that someone like AWS is a trusted third party that you can use. So AWS has a very strong history of providing great encryption solutions and having very kind of bulletproof and well-engineered solutions. So you can probably build that into your risk modeling to make the assumption that the systems they're providing natively are well tested and used at scale, versus then the simplicity of implementing this. So security in general and encryption in particular can be a very high overhead solution. It's critical to the way you manage the security and safety of your business in the cloud. And you want to make sure that you're taking full advantage of the turnkey or the simple solutions that meet your risk appetite, to minimize the effort and the overhead that you actually take on board as an organization operating that, or indeed leveraging a third-party managed services provider such as Rackspace to take on board some of those risk assessments and the operational management of this ongoing. So when I think about native encryption features and why you should use them, it really comes down to the 4 points up here on the screen. So how simple are they to use? How reliable are they going to be? Can you guarantee that those features are always going to be there and always going to be available? What's the level of integration across services? So obviously if you use a native encryption feature within AWS, you expect it to be integrated across multiple AWS services. A great example is the key management service and the integration that you have to help you use that across multiple other primitive services. The integration is key to that simplicity and ease of use. And then the predictability of it. Do you have a predictable interface method? Do you know exactly how it's going to function in given scenarios? Because it's an at-scale system that has the simplicity and the integration built into it by design, and you know that it's going to be there and available. Therefore, you can predictably rely on the fact that you're going to be able to encrypt and decrypt at high speed, at scale as necessary. And then when you talk about those native services within AWS, here are some of the AWS services that have encryption built into them. Now, obviously, Amazon runs at a very high pace of innovation, so they're continually adding to this list. But I tend to look at them as divided into two main categories. So you have the primitives or the building blocks. These are the services that you would use to formulate and build your architecture, and using the native encryption offerings within those services, such as EBS to be able to encrypt volumes, or RDS to be able to encrypt at the volume level, or within kind of TDE if you're using Oracle inside RDS. Those enable you to build a secure and safe data structure within your architecture without having to worry about building a single solution that covers everything from a single point. Using those native capabilities really simplifies the design and implementation of your architecture. And then when you move to the other end of the scale, you have the more fully managed offerings from Amazon. So when you look at some of their enterprise application space offerings, such as Workmail or Workspaces, even Redshift as a large-scale data warehouse, or Elastic Transcoder as a kind of self-contained media translation service. These are systems that are built to be used in their entirety as a contained solution, but they actually have the native encryption features built into the appropriate points within. So where you look at some of these services, they'll be built on the primitives that you see on the left-hand side of the screen. So they'll potentially be leveraging the same encryption services and offerings that you would use if you access the primitives directly, but they're wrapped up into a neatly managed and integrated solution for you.
Okay, so we talked a little bit earlier about kind of the key to encryption, obviously being the key, pun fully intended, and also how that key itself is plain text and unencrypted, unless you further encrypt it using envelope encryption, but then that's a hierarchy and you're left at some point with a key that's unprotected. So that unprotected key needs to be protected via means other than encryption. So we need to do that via more policy and other technologies to prevent the misuse or the misdistribution of your keys. Essentially, the keys are your data in the end. Again, we mentioned if you have the key, you have the data. So you need to be actively managing who or what can access your keys. So that's going to revolve around determining your data classification and usage policies again, who in your organization can access the data, for what purpose, at what time, and can applications act on a user's behalf? Can the application itself access the data? And can the cloud provider access that data? Maybe you have a policy where a certain type of data never goes in the cloud. That was entirely the norm just a couple of years ago, and kind of the tides are changing rather rapidly to where those policies are being deprecated in favor of moving more things to the cloud. But as we do that, we need to make sure that we're still setting up policies around protecting that data, because that data essentially is your business. So we also need to know how to revoke access to these keys. So if we know that a key has been compromised, we need documented policies and procedures around revoking those keys, because that it will happen. I mean, that essentially is the breach. When the keys are out in the wild, your data is then out in the wild. So you need to be able to remove those keys from the access. And the longer those keys are around, the more likely that becomes. So we need to rotate those keys. So we need a policy around key rotation and procedures in place to do that rotation. Whether that be manual or technology, they need to be implemented. And there's a lot of solutions around that, and especially within AWS, the key management service, the KMS that they provide, will do that for you. We'll do a lot of these things for you, so you can set up policies around who can access the decryption keys and when. You can set up auto rotation. You can set up a lot of these as enforced policies within AWS. So again, it's not should you, it's you must. There's no doubt about it. Rotating the keys adds protection. There's multiple reasons. So as computers continually get faster and more capable, especially with the advent of cloud computing, there are adversaries working on breaking these keys all the time, breaking the encryption, finding vulnerabilities in it. So we need to make sure that we are staying on top of that. There's also other solutions, so not just maybe maintaining the entire key, but you can actually split up the key and rotate keys in a split fashion, so that one part of the key is stored in one place, another part of the key is stored in another place. It makes it much harder to compromise those types of configurations. And again, anywhere that the native features exist within AWS, we should leverage them. So they're adding KMS support to products all the time. KMS itself is in every region except Beijing. So if you have access to it at a minimal cost, it's really a question of why are you not using it today?
Okay, thanks, Brad. And then finally, actually before I move on to best practice number 7, which is automation around encryption, again, I just encourage people to potentially throw any real-world scenarios or any real-world challenges that you guys might have, and we can talk to it at the end. Otherwise, we'll look at some potential example scenarios at the end and talk through them. But when we talk about encryption, I mentioned earlier, there's often a perception that there's a lot of overhead and operational management that needs to go into effectively managing encryption across a platform, especially if you're running many platforms within an organization. There's always going to be some level of isolation between different workloads, and therefore you're going to have different types of encryption that you need to manage across different sets of platforms with different data classifications and different data use policies. But ultimately, and I mentioned this right at the start of the hour, encryption works at its best when it's ubiquitous and automatic. So if you think about it today, the 2 forms of encryption that people use most often would be HTTPS URLs on your browser or on your phone, or the handset to tower link for your cell phone calls. So people don't tend to think about those as a method of encryption, or they don't tend to be aware of them as they happen, because it's so transparent and it works so well that you don't even really know they're there. I think if you asked any average cell phone user, they realized that there was a complex encryption system going on in the background every time they made a phone call, then I think most people would be surprised to hear that. And the same goes with HTTPS, particularly in the day of apps on smart devices where you have HTTPS web services on the back end, and people are just kind of hidden from that level of complexity and security by the nice user interfaces that exist. If you look at an e-com platform, or if you look at Amazon.com, they have an application for a smartphone. You would never know that everything is running over SSL for the back-end calls or for pulling data down or making the purchases. It works transparently, and therefore it makes it easy for the end user to consume. Now, that's not to say that it's easy for the people running those platforms to manage that, and that's where automation really comes in and plays a key part. So you heard, I imagine most people have heard the name of automate all the things. So automate all the secure things is pretty much the same. So when you start looking at using encryption, you need to figure out how to manage your key distribution methods. So securing and automating that distribution method reduces a significant attack surface effectively in the form of human error. So if you have a manual system of sharing keys, there's always going to be some level of risk around your key being compromised or accidentally leaked into the public domain, at which point, even part of your key, at which point you're suddenly opening yourself up to a much broader spectrum of risk. Automating that solution for distribution of keys, automating the collection or gathering of keys as you bootstrap services is really key to making sure that you eliminate that human error. The only real way to eliminate human error is to eliminate the human from the process. Brad was just touching on rotation of keys. It should be regular, and therefore, in order to be regular, you need to make sure that it's simple to achieve. So leveraging a service such as KMS or any other encryption management solution that you choose to build or leverage should be really automated to the point that you don't have to really apply that much effort or operational management into rotating your keys. It should be an automated process, and it should be something you can kick off on a regular basis. As a best practice, most people recommend rotating keys at least once a quarter for major services. That's not always achievable in the traditional world where you have to go around and manage outage or impact of a key rotation. By automating that in a cloud environment, you really reduce that overhead and therefore significantly increase your security posture by making sure that you have that continually evolving line of defense in rotated keys. And when you talk about user access control, so actually accessing some of the encryption infrastructure that supports it, accessing even something as simple as accessing the certificates on an ELB, for example, when you automate some of that access control, when you automate some of that change that needs to occur, you're removing, again, another risk vector, another threat to compromise of your data. So using things such as the Amazon Certificate Manager to be able to manage your keys without having to go and manually apply them across multiple ELBs, for example, is a great way in improving the posture of your security. And then finally, and this is the thing that I think everyone's aware of, but a lot of people tend to ignore when they look at it, is audit logs and audit trails. So a lot of people tend to look retrospectively. So if you pardon the phrase, a horse is already bolted at the point that you've been compromised, and you then look back to see where your encryption methodology was compromised, where your key was leaked. In order to make the use of your, in order to make use of your audit logs, you need to really be looking at them in an automated fashion and eventing and alerting of them in real time, so that you really understand when and where things are being compromised, or when and where, more importantly, people are attempting to compromise your encryption methods, because that's the real key part at which you need to be able to intervene and ensure that you're securing your data.
Yeah, just a little bit more on that last point. Unless you're doing real-time monitoring, it's impossible to do anomaly detection. You can't detect an anomaly in the past. So you need to be reviewing these logs on a very regular basis, if not in real time. And again, with AWS services, that's something that is made very possible today. It may not have been possible in your on-prem solutions just a couple of years ago due to the extreme cost associated with it. But now you can do it for very low expense. There's, again, no reason not to do it. The KMS service, if you're leveraging it within AWS, you'll be able to see every time a key is checked out and used, or if the key request is denied. So you can pick up on anomalies like that. So if somebody's trying to decrypt data that they don't have access to, you'll be able to detect that in real time and potentially be able to stop breaches before they happen. Because if it's just a brute force attack, then they keep trying different things until they finally find a way to get that key. So if you're able to see the first couple attempts in real time, you might be able to take other means to shut that breach down. All right, a couple questions have come in here. What's your recommendation on how to automate key distribution? So we're struggling with the manual effort of having to warn users and send encrypted emails distributing each and every key every 90 days. Yeah, so new key distribution is one of the toughest challenges. Essentially, when you're giving out a key, you're giving out access to the data. So there need to be methods in place for authenticating a user and ensuring that they are who they say they are before you give them essentially the key to unlock that data. So there are systems in place. Kind of distribution of keys is probably outside of the scope of what we were talking about here. We would love to follow up on that. I don't know if we have kind of the right people in place to answer that question. We actually have a managed service, managed security service where we take care of a lot of those things for our customers. So we would be very open to talking more about that with you. And second question, do we get access to this deck? I believe we will provide this content following the webinar. Kind of some additional advice. So remembering that the three main components of encryption are the algorithm, the key, and the data. All of those things need to be evaluated. So again, around the data itself, we need to come up with the policies. Not all of your data needs to be encrypted. Maybe it's some cat pictures that you're storing on a web server for whatever reason. You don't need to encrypt that if it's more hassle than it's worth. But as we talked about, it might be easier just to encrypt that entire volume transparently. So you would actually be encrypting it. Again, we talked about keys and key management systems. We need to make sure we're evaluating the technologies that do it in an automated fashion, as well as the policies and procedures for key rotation in a manual fashion. And we haven't talked a whole lot about the algorithm, but the algorithm is important. So these algorithms themselves are being compromised. While encryption itself is technically and mathematically almost unbreakable, there are flaws that are brought into the algorithm. So maybe the selection of the random number seed that they used to start the process was flawed when they came up with that code. So the method of encryption itself is not flawed, but the code that generates the first value, the seed value, may have been flawed and generating a number that you can predict, and therefore generating a way to break that encryption over time. So we need to be evaluating which algorithms we're using within the services that support multiple algorithms. And if multiple algorithms are not supported natively, you may have to evaluate other means to protect that data when you do find that the algorithm selected has been compromised or is not strong enough for the type of data you're choosing to protect. And we touched on this. The data protection requirements are policy driven. Nobody's going to tell you, what should or should not be protected. That is entirely an organizational decision. So you need to really figure out first, what data do you have? You need to do an analysis of what types of data you have in your organization, classify that data in terms of its sensitivity level, who should have access, why they should have access, and limit, obviously, things to a need-to-know basis and least privileged security model. When we have that sort of information in place ahead of time, it makes the decisions a lot easier. If we haven't done that consideration as to what is encrypted, when it's encrypted, and how, and we're not operating with sound guidance and policy around that, and we don't understand what our risk tolerance is, those are all key components to understand upfront. Then we can't define when to use encryption. So you need to have data usage policies and data classification policies in place before you even embark on this in a lot of cases. And we've touched on this over and over. Most of the AWS services support some form of encryption at some point somewhere in their operation. Some of them will natively do it transparently. You can lean entirely on the provider to provide you at least that entry-level support of encryption. So at least your data is encrypted at rest, done transparently by the provider. So yes, a provider would compromise your data, but it's entirely unlikely that would happen. And it's okay with your policy for that type of data. Why don't you do it? It's just check it by default and move on. But we do need to evaluate potential trade-offs. So we haven't touched on this a whole lot, but there are still performance impacts to using encryption in some cases. So if you're using an elastic load balancer in front of a large fleet of EC2 instances for your application, and you are encrypting all the way down to the EC2 instance, that means each one of those EC2 instances is using a certain part of its CPU and memory to process encryption. So that obviously is going to be the most secure way to do it. It's going to give you the lowest risk. But again, maybe that data that you're protecting doesn't warrant that level of protection, and you'd be just fine terminating that session on the elastic load balancer and freeing up those resources and thus lowering your AWS costs. I think we have some time here, so we can actually potentially walk through some scenarios. James, you want to touch on anything else?
Well, so I was just going to point out that we posted the real links for all of the useful links on this slide into the chat for this webinar. My apologies for shortening those links into a friendly-looking line without actually posting the links themselves in the deck. So yeah, we have some time left. I think we could maybe run through one scenario potentially and talk about where you might potentially encrypt data in transit or at rest on certain parts of an architecture. So unless anyone has a strong suggestion, I was going to suggest we look at kind of a simple e-commerce platform and where you might be looking to encrypt data in the different points and what you might leverage to do that. But do you feel comfortable talking about that at this point, or is there something else we should walk through as a scenario?
No, I mean, we can touch on a use case that we see quite frequently. E-commerce is and digital services is a very common platform that our customers are coming to us with. The biggest one of those being Magento. So we're seeing a lot of customers trying to stand up a storefront using Magento and really struggling with compliance questions. Am I going to be processing credit cards? Yes. Well, then I need to be PCI compliant. What does that mean? Can I use these services? PCI compliance says I need to do X, Y, Z. So one of the things that we would love to help you with is understanding what that requirement means and helping you build a secure solution from the ground up. So we have a lot of experience with doing this on the Magento platform, and using the AWS native services and their encryption capabilities, you're able to achieve a very secure platform, which would be fully PCI compliant. Just using the native capabilities with the AWS KMS, the key management service, in place actually meets the PCI requirements to achieve PCI compliance. So you could actually build the Elastic Load Balancer in front of your web servers. So you would set up the certificate on the Elastic Load Balancer to do the encryption in transit. So we've talked about that, the TLS component, because that would be done by the ELD. You can actually leverage integration with the certificate management service to rotate the certificates on the load balancer automatically, and that will actually have a back-end integration with the KMS service. Then on each EC2 instance behind the load balancer, we can set up transparent encryption at the EBS volume. So we would basically check a box that we're going to leverage encryption on the volume for each one of those instances. And again, that would interact transparently behind the scenes with the KMS service to get the keys necessary to encrypt the volume, the entire volume. Behind that, we frequently would stand up an Aurora, Amazon Aurora database. That service, again, would leverage potentially a TLS session on the endpoint. So the web instances can actually connect to the database instance over another secured channel. So that would be another TLS session, another integration for the KMS service to rotate those keys. And then within the database, you could actually choose to encrypt the volumes as well. So that, again, transparent. These are all almost checkboxes. A couple additional parameters to maybe say which key, customer master key within KMS you're using. But once that's done, it's all automated. So we've now done encryption in transit. We've done encryption and rest on kind of the web tier. We've done encryption in transit to the database tier. We've done encryption at rest on the database. You could even look at leveraging encryption within the database if you have highly sensitive data. And at this point, that would need to be something you would build into your application code. But you could still leverage the KMS service to do the key management for you. So you could actually check out a key to do the encryption and decryption within your application of data that's in the database directly. So that's just kind of an overview of how the different technologies would interact with the different services and all of the native options out there. So this isn't extremely complicated to implement. It's something that AWS has made very easy, and they really want every customer to take full advantage of those capabilities. Okay. Are there questions coming up?
We'll just give people a few minutes for any questions you might want to fire over to us. But otherwise, we will start to wrap up this webinar in a moment. Okay. But before I move on and wrap this up, I guess I just want to ask, anyone have anything other than an e-commerce platform that they're really interested in? Kind of any general discussion around encryption or how you might use encryption to secure it? Are there any particular platform types that we have a large contingent of out there that people are interested in talking about? We have a couple of minutes left. It would be valuable if you guys want to push anything forward for us, and we can talk through it right now. Otherwise, please feel free to reach out to us afterwards. We'll obviously put a link up to our blog, and actually an expanded link so you can read it in clear text this time, to reach out to us after the webinar if you have any follow-on questions. See, we have a hand raised. Just bear with us while we wait to get the question. So the links that are on the screen at the moment have been pasted into the general chat window, expanded, just to make sure that everyone gets them now. And when I move on a slide, there'll be a link around our blog and the Rackspace AWS page where you can find contact details for the rest of us. So I'm just going to advance to the final slide and start to wrap this up. So no good security discussion finishes without some kind of brightly coloured unicorn, mythical type creature. So had to throw one in here for the final slide. But I just wanted to take a moment to thank everyone for taking the time out to attend the webinar today. We always appreciate the chance to talk to you guys, have you throw any questions at us, and really talk a little bit about the AWS platform, some of the opportunities that you can leverage technologies within the AWS platform for, and where Rackspace can potentially help you out. So you see up on the screen right now, we have rackspace.com/AWS is the site for our Fanatical support for AWS offering. There's a lot of information there where you can find out about our tooling, our automation, some of our best practice, and links to some of our other webinars, pre-recorded and white paper content. And then we also have a blog at blog.rackspace.com/AWS, where you can go and find articles written around a variety of AWS-related topics by myself, by Brad, and other members of our architecture group. You can also find contact details for the individual architects, for myself and Brad on there. We have profiles on there with our contact details, or reach out to us via the webinar registration if you have any following questions. So the final question that came in was unable to get the links from the last slide. So we'll just repost them in the chat window again. So if you look in chat where you're currently typing questions, I'm about to repost the links there. So you'll be able to get them. And if that still doesn't work, so I've just reposted them now. If that still doesn't work, then we will find a way of including the links when we send around the recording to this webinar, so that you can see the links and the link to the recorded webinar to review at a later time. So unless there are any other questions, we'll wrap this up. Give everyone 9 minutes of their day back. Again, thank you very much for attending. Please feel free to reach out to us if you have any questions around encryption on AWS or anything else related to the Fanatical support for AWS. We're here to answer the questions and talk to customers. So thank you very much. Everyone have a great day, and we'll hopefully see you at the next webinar.
Yep, thank you, everyone.